Good morning all. The next topic is magnetic flux and Gauss's law for magnetic field. Magnetic flux is defined as the number of magnetic field lines passing through a given closed surface. We represent the magnetic flux as the dot product of the magnetic field and the area vector A, that is phi is equal to B dot A, that is equal to BA cos theta. To explain, three figures are drawn on the right hand side. Area vector is the vector that is normal to the area, and in the first figure the magnetic field and the area vector are parallel. Therefore phi is equal to B dot A becomes BA cos 0, that is BA. In the second figure, the area vector and the magnetic field are right angles to each other. Therefore phi, which is equal to BA cos 90, will, that is 0. And in the third case, the area vector is making an angle theta with the magnetic field, where we can say the magnetic flux phi is equal to BA cos theta. Next, let us discuss what is the Gauss's law for magnetic fields. We have seen the Gauss's law in electrostatics. What is the Gauss's law for magnetic fields? Consider a closed surface called a Gaussian surface in a magnetic field. Consider a closed surface called a Gaussian surface in a magnetic field. And from the figure, you can see that the number of magnetic field lines entering the Gaussian surface and the number of field lines emerging from the Gaussian surface are same. Now, what is the magnetic flux then? To find out the flux, you consider a small area dA on the Gaussian surface. Then the magnetic flux that is passing through the small area dA, that is B dot dA, where B is the magnetic field at any point on the surface. We can represent d phi as B dot dA. Then what is the total flux passing through the Gaussian surface? Since it is a closed surface, we can say that the total flux passing through the Gaussian surface is closed integral B dot dA. That is closed integral B dot dA. Now from the figure, you can see that the number of field lines entering and leaving the Gaussian surface are equal. The net magnetic flux through the closed surface, that is a net magnetic flux through the Gaussian surface, is 0. Hence, closed integral B dot dA equal to 0. This is called the Gauss's law for magnetic field. Thus, the Gauss's law for magnetic field can be represented as closed integral B dot dA is equal to 0. Why it happens? Because the number of field lines entering and leaving the Gaussian surface is equal. Therefore, the net magnetic flux through the closed surface is 0. Now, what is the significance of Gauss's law in magnetic field? The significance is that magnetic monopoles does not exist, and we can explain all magnetic phenomena using magnetic dipoles only.